So today we're going to be answering the question of why does a magnet fall more slowly through a metal pipe than a neutral metal sphere. So just for simplicity's sake, we're going to say we have a copper pipe and we're going to have a bar magnet with north oriented downwards. So when we have the dipole magnet, we're going to have a dipole magnetic field, which you can see here in green, and it has the magnetic field lines coming out of north. As the magnet falls, any point below the magnet is going to feel a net increase in the magnetic field, as the magnetic field is distance dependent and the strength is going to increase as it gets closer. So in effect, B initial will be smaller than B final. According to Faraday's law, a change in the magnetic flux will induce a curly electric field. And as we said earlier, B initial is smaller than B final, so there will be a change in the magnetic field. It's going to be in the down direction. Faraday's law says that the induced curly electric field is going to be in the direction in which your fingers curl when your thumb is pointed in the direction of negative delta V delta T. This means that the induced curly electric field is going to be produced as labeled E and C. Because the pipe is made out of copper, which is a metal, it has delocalized electrons that are free to form a current due to the curly electric field. While the electron current I opposes the curly electric field, the conventional current is in the same direction as the curly field, as you can see here. According to Biot-Savart Law, the conventional current will create its own induced B field, as you can see here in green. You can compare this B field that is created by the current to the B field of the magnetic dipole. As you can see, the B induced and B dipole are anti-parallel, meaning that they will cancel each other out. And this is consistent with Faraday's law, which says that the system will resist a change in its magnetic flux. Because further analysis is more complex in the scope of this class, it is sufficient to say that these induced B fields are going to cause the magnet to feel a drag force, which is going to slow it down as it falls. The neutral metal sphere does not have a B field to begin with, so there will not be drag, which means that it's going to fall through faster than the bar magnet will. And that explains why a magnet falls more slowly through a metal pipe than does the metal sphere.